There. You know how we always gravitate toward the simplest explanations,
Mm-hmm.
like Occam's razor?
Right.
The simplest answer is often the right one.
Yeah.
Well, today, we're diving into a framework that takes that idea and turns it into a powerful tool for understanding data.
Okay.
The minimum description length principle,
Uh-huh.
or MDL.
It's a bit like finding the most elegant way to pack a suitcase, you know? You want to fit everything in neatly without any wasted space. MDL is all about finding that perfect fit.
Okay.
But instead of clothes, we're talking about data and explanations.
Okay, I'm intrigued.
Yeah.
So instead of cramming socks into shoes,
Mhm.
we're looking for the most compressed, most efficient way to describe patterns in data.
Exactly.
But how does that actually work?
Well,
How do we measure simplicity when it comes to data?
imagine you're trying to explain something complex to a friend, right?
Okay.
The clearer and more concise your explanation, the better they understand it, right? MDL applies this same logic to understanding data. The simplest explanation is often the best.
So a concise, elegant explanation is like a compressed file. Less is more.
Exactly.
But how do we apply that to, say, stock market data?
Okay.
I can't imagine a simple explanation for those chaotic ups and downs.
You're right. It's not about finding one magic formula for everything. It's more about having different tools for different jobs.
Right.
Think of it like this. You wouldn't use a hammer to fix a leaky faucet, would you?
Definitely not. I'd probably end up flooding the kitchen.
Exactly. The same goes for data. We need different models, different tools to understand different types of data.
Okay.
Some models are great for predictable patterns, like the phases of the moon,
Yeah.
while others are better suited for more complex dynamic systems,
Okay.
like the weather.
Right.
Or, yes, even the stock market.
So different data, different models, but how do we choose the right tool for the job?
Right.
This is where MDL comes in, right?
Yeah. You got it. MDL helps us choose the model that provides the most concise, most compressed description of the data.
Okay.
It's like finding the model that tells the most efficient story, the one that cuts through the noise and gets to the heart of what's really going on.
That makes a lot of sense. It's about finding the most elegant explanation, the one that fits the data like a glove.
Yeah.
But how do we actually measure that elegance?
That's where information theory comes in. We use something called codes.
Gotcha.
Think of them as specialized languages for describing data.
Okay.
And just like with any language, some codes are better at conveying information than others.
Right.
A good code can compress data with strong patterns,
Yeah.
making it much shorter and easier to understand.
So a good code is like shorthand. It lets us express the same information with fewer symbols, fewer bits of data.
Exactly.
Right.
And the more a code can compress the data,
Yeah.
the more regularity,
Yeah.
the more inherent structure it has uncovered. Think about it. A random sequence of coin tosses is hard to compress. Yeah.
Because there's no pattern,
Right.
no structure to exploit,
Okay.
but a sequence with all heads.
Yeah.
That's easy to describe. Just say all heads.
So the more random the data, the harder it is to compress,
Right.
the less elegant the explanation. I'm starting to see how this connects to MDL.
Yeah.
We're looking for the model, the code, that gives us the shortest, most elegant description of the data.
You're getting it.
Okay.
And this approach,
Yeah.
this search for the shortest description has some pretty deep implications.
Okay.
It's not just about finding patterns in data.
Yeah.
It's about understanding the fundamental nature of knowledge itself.
That's a pretty bold statement.
Yeah.
But I'm definitely interested in learning more.
Okay.
Before we get too philosophical, though, I'm curious about how this all works in practice.
Sure.
How do we actually apply MDL to real-world problems?
Well, there are different approaches,
Okay.
different levels of complexity. There's a concept called crude MDL.
Crude MDL.
Yeah.
Which is a good starting point.
Crude MDL sounds a bit rough around the edges.
It is a bit simplistic, but it helps illustrate the core idea. Imagine you have a set of potential explanations for your data, like different models for predicting, say, the weather.
Okay, so we have a model that looks at historical temperatures.
Right.
Another that factors in ocean currents.
Mm-hmm.
Maybe one that analyzes butterfly migration patterns,
Yeah.
Just for fun.
Exactly.
Okay.
Crude MDL would essentially go through each of these models and figure out how much space it takes to describe both the model itself
Okay.
and how well it fits the actual weather data.
So it's like saying, okay, this model is pretty simple to explain,
Right.
but it doesn't really fit the data very well.
Yeah,
Well, this other model is a bit more complex, but it fits the data like a glove.
precisely.
Okay.
And crude MDL would say, all right, let's go with the model that requires the least amount of information overall.
Okay.
The one that's most elegant in terms of both its own description and how well it fits the data.
Because that model is essentially the most compressed explanation.
Exactly. But, as you might guess, crude MDL has its limitations.
Like what?
Yeah.
Does it only work on Tuesdays or something?
Not quite. One issue is that it doesn't really tell us how to encode the models themselves.
Okay.
We know we want to choose the shortest code possible,
Right.
but without any guidelines, we could end up making arbitrary choices that skew our results. We need something more objective,
Okay.
more refined.
So we need a system for comparing apples to apples, so to speak.
You got it. And that's where the concept of refined MDL comes in, which utilizes something called universal coding.
Okay. This is getting good.
Yeah.
Universal coding. Tell me more. It sounds like something out of a sci-fi movie.
Imagine you have a set of codes, each designed to compress specific types of data. It's like having different file formats for images, music, and text documents.
Right, like JPEGs for pictures, MP3s for music.
Exactly. Now, a universal code is like a master key. It can compress data almost as well as the best specific code for that data,
Okay.
even if you don't know which specific code is best beforehand.
This is like having a universal travel adapter that works anywhere in the world, even if you didn't know where you were going to need it.
That's a great way to put it.
Mm-hmm.
And one of these universal codes, a particularly important one for refined MDL, is the normalized maximum likelihood code.
Okay.
Or NML for short.
NML, catchy.
Now, this NML code has a really cool feature.
Okay.
It treats all models equally.
Okay.
There's no bias, no favorites.
So it's like a level playing field for models.
Exactly.
No one gets an unfair advantage.
Exactly. This is really important because it means that the NML code is as objective as possible when selecting the best model for the data.
Okay, I think I'm following so far.
Good.
We're trying to find the model that gives us the shortest description of the data using this NML universal code.
Right.
But how does this actually work in practice? Can you give me some concrete examples?
Of course. Let's imagine a simple example, a sequence of events, like a series of coin tosses.
Okay.
Let's say you observe a sequence of heads and tails,
Okay.
and you want to find the best model to describe this sequence.
Okay.
Right.
Okay.
Now, using refined MDL,
Yeah.
we'd use the NML code to see how many bits it takes to describe the sequence
Okay.
using each model.
Okay.
The model that gives us the shortest code,
Right.
the most compressed description, wins.
So it's like comparing how efficiently each model can tack the data.
Right.
The model that achieves the tightest fit with no wasted space is the most elegant explanation.
That's the heart of it. And this approach scales beautifully.
Okay.
We can use it for much more complex data and models.
Right.
The principle remains the same.
Ah.
Always seek the most compressed, the
Yeah.
most elegant description.
This is really clicking for me.
Yeah.
We're finding the most elegant explanation for the data,
Right.
not just the one that seems to fit at first glance.
Yeah.
But you did mention some limitations of refined MDL.
Earlier. Right. Like any powerful tool, it has its quirks.
Okay.
One thing to keep in mind
Yeah.
is that even though refined MDL is more efficient than the crude version,
Right.
it can still be computationally demanding
Okay.
for large data sets and complex models.
Because we have to run the calculations for each model,
Right.
each potential explanation
Yes,
that can add up quickly.
exactly.
Um,
Another aspect to consider
Yeah.
is that MDL is sensitive to the model class we choose.
Okay.
It's like choosing the right category for a book in a library.
Okay.
If we pick too narrow a category,
Yeah.
we might miss out on connections to other interesting books.
So you need to make sure we're not limiting our options too much.
Right.
Otherwise, we might miss the bigger picture.
Right. But if we go too broad, we risk overfitting,
Okay.
finding patterns that aren't really there.
Right.
It's about finding the sweet spot,
Okay.
a model class that's broad enough to capture the essence of the data, but not so broad that it starts fitting to noise.
So it's a balancing act.
Yes.
But isn't there a risk that none of the models we're considering actually represent the data well?
Yeah.
What happens then?
That's a great point. It's like trying to find the best apple in a barrel of oranges.
Right.
If none of our models truly reflect how the data was generated,
Right.
even the best one might not be very useful.
So what can we do about it? If our current set of models isn't cutting it, where do we go from there?
That's where things get really interesting.
Okay.
It often requires us to rethink our assumptions.
Okay.
Maybe expand our model class.
Okay.
Gather more data.
Yeah.
Or even consider entirely new approaches.
So MDL is not just a recipe to follow blindly.
Right.
It's a framework for asking the right questions.
Exactly.
And guiding our exploration of the data.
Exactly. And it's crucial to remember that MDL is a tool.
Yeah.
And like any tool, it has its limitations.
Okay.
It's not about finding the perfect model, but rather using these principles to improve our understanding of the data.
That makes a lot of sense.
Yeah.
It's about using this lens of compression and elegance to guide our analysis.
Right.
Not just crunching numbers blindly.
Exactly. Yeah.
Speaking of which, I know we've talked about some technical details.
Yeah.
But what I find most fascinating is how MDL connects to other big ideas.
Absolutely.
Right.
It's not an isolated concept.
Right.
MDL has deep connections to information theory,
Okay.
Bayesian statistics,
Yeah.
even machine learning.
It's like MDL is this central hub,
Right.
this crossroads where all these different paths of knowledge intersect.
You could say that. By bringing together insights from these different fields,
Yeah.
MDL provides a powerful unifying framework
Okay.
for understanding data and extracting meaning from it.
Okay, I'm convinced.
Yeah,
MDL's pretty darn cool.
it is.
But how does all of this theoretical coolness translate into real-world usefulness? Give me some examples.
MDL has been used in an incredibly diverse range of fields,
Okay.
from physics and astronomy
Wow.
to biology, finance,
Okay.
even art.
Wow. So it's not just for academics.
No.
It has real-world applications.
Absolutely. For example, in image processing, MDL is used to develop algorithms that remove noise from images
Okay.
while preserving important details.
Okay.
Think about those old, grainy photos.
Yeah.
MDL helps us bring them back to life.
That's amazing. It's like MDL is giving these old photos a fresh coat of paint, removing the noise of time and revealing the hidden detail.
Exactly. It's about finding that balance.
Yeah.
Removing the irrelevant information while preserving the essential elements.
Okay.
Just like we were talking about with model selection.
It's all connected. I'm curious, what are some other examples?
Sure.
How is MDL being used in other fields?
Well, in bioinformatics,
Okay.
MDL helps analyze DNA sequences,
Okay.
potentially uncovering patterns that could indicate disease or other crucial biological information.
Wow. So MDL is helping us understand the very building blocks of life.
Yeah.
That's incredible.
It is remarkable.
Okay.
And in finance,
Yeah.
MDL has been used to develop trading strategies that can potentially predict market movements more accurately than traditional methods.
Okay, you've got my attention.
Yeah.
So MDL can help us understand the past, predict the future,
Right.
and maybe even make better decisions in the present.
Yeah.
But I'm also wondering how MDL compares to other more traditional statistical methods.
Okay.
Like, what about maximum likelihood estimation?
Ah, yes. MLE.
Yeah.
A classic.
Okay.
It's a widely used method for estimating parameters in statistical models.
Okay.
However,
Yeah.
it has a tendency to overfit the data,
Okay.
meaning it sometimes creates models that are too complex,
Okay.
too tailored to the specific data they were trained on.
So it's like that saying, when all you have is the hammer, everything looks like a nail.
Right.
If you're always using MLE, you might end up with overly complex models that don't generalize well to new situations.
Exactly. And that's a key advantage MDL has over MLE.
Okay.
Its focus on finding the simplest explanation helps avoid overfitting. It's like a built-in safeguard against overly complex models.
So MDL is like that minimalist friend who always seems to have the perfect clutter-free apartment.
Yeah.
Everything has its place and there's no wasted space.
I like that analogy. And because of this inherent preference for simplicity,
Yeah.
MDL often performs better than MLE,
Okay.
especially when dealing with limited data or complex models.
I like that saying, less is more. What about other model selection methods?
Sure.
Like AIC or BIC?
Okay.
How does MDL stack up against those?
AIC and BIC are both popular methods that, like MDL, try to balance model fit with complexity.
Okay.
However,
Yeah.
they differ from MDL in a few key ways.
Well, look what?
One important difference is that AIC and BIC rely on approximations that are only accurate when you have a lot of data.
Okay.
MDL, however, is grounded in information theory
Okay.
and doesn't rely on these approximations,
Yeah.
making it more accurate even with smaller data sets.
So it's more robust,
Exactly.
more reliable when we don't have mountains of data to throw at the problem.
Exactly.
Okay.
Another key difference is that while AIC and BIC penalize model complexity based solely on the number of parameters in the model,
Okay.
MDL takes a more nuanced approach.
So it's not just about how many knobs and dials a model has,
Right.
but also how those knobs and dials are tuned,
Exactly.
how they interact with each other.
Exactly. This makes MDL's measure of complexity more sophisticated,
Okay.
potentially leading to more insightful model choices,
Okay.
especially when dealing with those intricate, multifaceted models.
Okay, I'm seeing more and more why MDL is such a powerful tool. It's not just about finding any solution. It's about finding the most elegant, most insightful solution,
Right.
even when things get complex. We've been digging deep into the mechanics of MDL, comparing it to other approaches. But before we wrap up,
Yeah.
I'm curious about something.
Sure.
You mentioned earlier that MDL isn't just for statisticians.
Uh-huh.
It's a way of thinking about the world.
Right.
What did you mean by that?
Well, think about it. Every day, you're bombarded with information.
Right.
From news headlines to social media feeds to that never-ending stream of emails,
Yeah.
right? How do you make sense of it all?
It can definitely feel overwhelming sometimes.
Yeah.
I try to filter out the noise and focus on what's important,
Right.
but that's easier said than done.
Exactly. But without even realizing it,
Yeah.
you're already using the principles of MDL in your everyday life.
Okay.
Every time you summarize a complex article into a key takeaway,
Yeah.
or you choose a shortcut to avoid traffic,
Right.
you're essentially searching for the most concise, most efficient representation of information.
So we're all data compressors at heart.
Mm-hmm.
We're constantly looking for those elegant shortcuts,
Yeah.
those simplified explanations that help us navigate the complexities of the world.
Precisely. And that's why understanding MDL can be so powerful.
Okay.
It gives you a framework for thinking critically about information,
Right.
for separating signal from noise,
Okay.
and for finding those elegant, efficient explanations that make the world a little bit easier to understand.
That resonates with me. In a world overflowing with data and competing narratives,
Yeah,
MDL feels like a superpower.
it is.
The ability to cut through the noise and get to the heart of the matter.
It's definitely a valuable tool, and the beauty of it
Yeah.
is that you don't need to be a mathematician
Right.
or a computer scientist to appreciate its power.
Okay.
By understanding the basic principles of compression,
Yeah.
elegance,
Okay.
and finding the simplest explanation,
Right.
you can apply this way of thinking to almost any aspect of your life.
This has been a real eye-opener.
Yeah.
I feel like we've gone from data compression to life philosophy in just a few short steps.
And we've only just scratched the surface.
Right.
There's so much more to explore with MDL, its connections to other fields,
Yeah.
its potential applications in areas like artificial intelligence and machine learning.
It sounds like MDL is a field with endless possibilities. I have a feeling this isn't our last deep dive into this fascinating topic.
I certainly hope not. It's been a pleasure exploring these ideas with you.
The feeling is mutual. And to our listeners, thank you for joining us on this deep dive into the elegant world of minimum description length. We hope you've gained some valuable insights and maybe even a new lens through which to view the world around you. Until next time, keep exploring, keep asking questions, and keep searching for those elegantly compressed explanations.